Hello students, today we're going to cover section 6.4, properties of rhombuses, rectangles, and squares. The first thing we need is the vocabulary. Most of these words we should have heard before. A rhombus is a parallelogram with congruent sides. A rectangle is a parallelogram with 4 right angles, and a square is the combination of both a rhombus and a rectangle. So the first kind of problem we might see is classifying special parallelograms. So one of the things that we might be asked to do is identify the different special parallelograms in a picture like this stained glass window. In the top left-hand corner, you can see this small pane is most likely a square. We can also see these red panels, which are most likely rectangles. And finally, if we were to search for a rhombus, we might see something like a rhombus in this center panel. The first two theorems in this section cover rhombuses. The first one says if a parallelogram is a rhombus, then its diagonals must be perpendicular. The second theorem says if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles, which in this case cause angles 1 to be congruent to angle 2, angle 5 to be congruent to angle 6, angle 3 to be congruent to angle 4, and angle 7 to be congruent to angle 8. Additionally, since we know that opposite angles of a parallelogram are congruent, we can say that 1 is congruent to 2, is congruent to 5, is congruent to 6, and 3 is congruent to 4, is congruent to 7, is congruent to 8. So given the fact that ABCD is a rhombus, we want to prove that the diagonals of ABCD are perpendicular. This is the first theorem that we saw in the previous slide. The first statement that I would make would be the definition of a rhombus. So we have ABCD, which is a rhombus. And that's given to us. By the definition of a rhombus, we know that all of its sides have to be congruent. So let's go ahead and mark that in our diagram. So if we think back to the previous chapter, and we remember the converse of the perpendicular bisector theorem, we might remember that if A is the same distance from two endpoints of a segment, then it must exist on the perpendicular bisector of that segment. So in this case, we can say, since AB and AD are congruent, A must exist on the perpendicular bisector of BD. And therefore AC is perpendicular to BD. So one of the questions that we can answer with this is the algebraic question asking us to find the missing angle measures in the given rhombus. Based on the second theorem that we saw, we know that P and R, being opposite angles of this parallelogram, have to be bisected by this diagonal. So one of the things that we know is all four of these angles have to be exactly the same. If we then look specifically at triangle PQR, we can see that triangle PQR is isosceles. So we start with 180 degrees that we know exist in a triangle. Subtract the given measure of Q, which is 104, so we're left with 76 degrees. And because angle 1 and angle 3 have to be of equal measure, we can take 76 and divide that by 2. So we know that both of those angles must measure 38. And since they're all congruent, we know that 1, 2, 3, and 4 all measure 38 degrees. Our final theorem of the day says that if a parallelogram is a rectangle, then its diagonals are congruent. So in this case, again, we can solve an algebraic type problem. If Ln is 4x minus 17, so we have this total length right here is 4x minus 17, and we have m to o, which is given by 2x plus 13, and we know that these are diagonals of a rectangle, we can set them equal to each other. So we have 4x minus 17 equals 2x plus 13. If we subtract 2x from both sides, on the left-hand side, we get 2x minus 17 equals positive 13. By adding 17 to both sides, we find that 2x has to equal 30. And therefore x must equal 15. Please be very cautious because this question actually asks what are the lengths of the diagonals. So we need to plug x equals 15 into one of them to solve. So in this case I would take 2x plus 13 and plug in the 15. So we have 2 times 15 plus 13. 2 times 15 is 30, and 30 plus 13 equals 43. So the diagonals of LMNO are 43. So I want to cycle back around to the vocabulary slide because I want to remind you of one very important fact. And that is squares are always rhombuses, but rhombuses are not always squares. Squares are always rectangles, but rectangles are not always squares. So if we wanted to create a Venn diagram of this relationship, we could create two circles. In the left-hand circle, we would have rectangles. In the right-hand circle, we might put rhombuses. And their overlap, what is both a rectangle and a rhombus, that's where we would put square. So that concludes today's lesson, section 6.4, properties of rhombuses, rectangles, and squares. Hopefully now you have the ability to classify and define special types of parallelograms.